Problem number 10. A calculator has a random number generator button which, when pushed, displays a random digit between 0 and 9. The button is pushed 4 times. Assuming that the numbers granted are independent, what is the probability of obtaining 1, 0, 1, 5, and 2 9s in any order? So, sample exam 4 of 8, problem number 10, we want to know the probability that we get 1, 0, 1, 5, and 1 or 2 9s. So this is the classic multinomial setting where each of the outcomes has a probability of 1/10 of happening. And so in 0, you know, number of zeros we get, number of 1s, number of 9s, and this is the case. And so we just plug in values. So we want 1, 0. We want 0 1s, and we just do that. 1, 0, 1, 5, 2 9s, we get this. And then that simplifies to this, which is one of the answers. Number 11. Mr. Flowers plants 10 rose bushes in a row. 8 of the bushes are white and 2 are red. And he plants them in random order. What is the probability that he will consecutively plant 7 or more white bushes? Now, number 11, there's not a slick formula that I could know or find to do this. And so I think this happens occasionally where they just want you to do it, you know, I'm going to say the hard way, but to enumerate all possibilities, to think about it. So here, the probability that we plant, the total number of ways to plant the 10 bushes is this, 10 factorial over 8 factorial times 2 factorial, which is 45 different ways. And then now we have to think about how many ways can we plant 7 in a row. And so I developed this, I'm going to call it a little bit silly methodology to do this, and you can develop your own way. But I let a square be a red ball, or a red bush, bush, not ball, and a circle be a white ball, and a circle with a 7 be 7 in a row. So this is one setting where we have 8 white bushes and 2 red bushes. That's one possible way. Now let's mix these up. We could have 7 white, red, 7 white, red, white, and so forth. And these are the only possibilities. So there's 9 possible ways that we could mix this up and have at least 7 white in a row. So the probability that we have 7 white in a row, at least 7, so 7 plus, is 9 over 45, which is 1/5. Number 12, let x have the density function f of x, which is equal to 3x squared over theta cubed, where x is between 0 and theta. If the probability that x is greater than 1 is equal to 7/8, what is the value of theta? So number 12, we were given that the probability that being greater than 1 is 7/8. So here, to find the probability of being 1 or more is this. So we integrate that, and that's x cubed over 3, so that cancels. We get this. We plug in our limits of integration. We get this. And the problem says it's equal to 7/8. So if we take this negative, subtract that over, we get 1/8 is equal to 1 over theta cubed. And clearly 8 and theta has to equal theta cubed, which means theta is equal to 2. Number 13, a random sample of size 16 is to be taken from a normal population having mean 100 and variance 4. What is the 90th percentile of the distribution of x bar? So problem 13, we want to find the 90th percentile of x bar. And we set it up like this. We set the probability that x is less than or equal to p sub 0.9. So that's a quantile. And later I'm gonna drop the 0.9 and just call it P, but really it needs to be a 0.9. And this probability is equal to 0.9. That's what the definition of a quantile means. So if we subtract the mean from both sides and the standard deviation associated with X bar, we get this. So the probability that Z is less than this quantity. And if you look up in a Z table, the probability of being less than some value to be 0.9 is 1.28. So this quantity here has to equal 1.28. So to simplify it, so the square root of 16 is 4, so 2 over 4 is 1/2. So since you divide by a fraction, you can invert and multiply, so that's 2p minus 200. That's where I get this step. Solve for p, we get 100.64. Number 14, a normal population is known to have a mean of 10 and unknown variance of sigma squared, which is positive. Based on a random sample of size n, what is the maximum likelihood estimator of theta squared? So number 14, we are asked to find the maximum likelihood estimator of sigma squared. So this is the likelihood of a sample of size n. We're given that the true mean is 10, so that's why I plug in a 10 here to the likelihood function. And then we take the natural log of both sides. So here, when we take the log of this, the n can come out front, and we take the log of that. Now here, if we raise sigma to the top, it's going to be sigma to the -1. The -1 can come out, but when you take the natural log, that minus n goes out front, which is this. And then the natural log cancels with e, just leaving this quantity, which is this. So now we take the partial with respect to sigma, and this is a constant, so it drops out. We get minus n over sigma, and here I like to raise that up, so sigma minus 2, so then the derivative would be minus 2 times sigma to the -3, so then it goes back down, and that's how we get this. And the 2 cancels with the that 2, and the derivative cancels with that 2, and that's a negative, change it to positive. So set it equal to 0, multiply through by sigma cubed, and we're left with this. And then take this to the other side, divide by n minus n, and we get sigma squared is equal to the sum of xi minus 10 squared divided by n. Number 15, suppose the joint density function of x and y is defined by f of x, which is equal to 10 times x times y squared, where x is between 0 and y is between x and 1. What is the expected value of x squared given y is equal to little y? So number 15, we're asked to find the expected value of x squared given y. So first of all, we need to find the marginal distribution of y. So that means integrate out x, and x goes from 0 to y. So here's our joint density. We're integrating with respect to x, so then it becomes x squared over 2. So the 2 and the 10 cancel to 5. We plug in our values, we get 5y to the 4th. So now to find the expected value of x squared given y, well, we leave that x squared here, and then this is the joint density divided by the marginal density, and the 2 and the y squared are constants, so they can be factored out, and the x's combined. Then we get integrate, you get y to the 4th over 4, limits of integration, we get y squared divided by 2. Number 16, events S and T have probabilities. Probability S equal to probability T equal to 1/3, and the probability of S given T is 1/6. What is the probability of the complement of X intersect complement of T? So number 16, Here we're asked to find the probability of S complement intersect T complement. And the trick to this problem is to realizing that that equals 1 minus the probability of S union T. I think that's the whole crux of the problem. You can solve it in a different way, but this simplifies it. And then to find this, it's the standard probability S plus probability T minus their union, but their union is the same as the probability T times S given T. And I do this because we're given those values. So you plug them in, simplify, you get 7/18. Problem 17, let y and z be two random variables. If the variance of y is 4, the variance of z is 16, and the covariance of y and z is equal to 2, what is the variance of 3z minus 2y? So problem 17, we're asked to find this variance of this. So then we take it in to the expression and bring it out constant squared. So that's 3 squared times the variance of z plus 2 minus 2 squared times the variance of y. Then it's plus 2, which is always in the covariance piece of this, times 3, which is that, times a minus 2, which is that, times the covariance of each of those. And we're given these values here, variance of y, variance of z, and the covariance. So that expression becomes this, which the answer is 1/6. Number 18, consider the regression model yi equal to beta 1 xi plus beta 2 wi plus epsilon I, where I goes from 1 to n. And the data points x1, w1 through xn, wn are fixed constants. Let the independent random samples, epsilon 1 through epsilon n, have a mean 0 and a common variance sigma squared. What is the least squares estimate of beta 1 if it is given that the sum of the xi squareds is 1 and the sum of the wi squareds is 1? So problem 18, we're given a line of b1 xi plus b2 wi, and we're asked to find the least squares estimate of b1 and b2. So we set up the sum of the square differences between our data and the proposed line. We take the derivative with respect to beta 1, which is this, set it equal to 0. And then I'm going to start solving for beta 2. But in this, when we simplify this, the 2, if we divide both sides by 2, this goes away. We take in the xi, and that's xi squared. So remember that this becomes 1 because it's given in the problem that it is, and then that is this. So then in this expression we solve for beta 2, which is here. And actually it only asks us to solve for beta 1, but so then here we take the partial with respect to b2 or beta 2, and we get this, and then when we set it to 0, that 2 can go away, and then we multiply this w in, and the wi squared. In the problem it says it's equal to 1. So now we solve for beta 1 and we get this. Okay, but we're given, we solve for beta 2 up here, so we plug this into here, which then we have one expression all in terms of beta 1. And then now we start simplifying it. So this piece was the beta 2. When we get this, so here we combine the fractions up top, and then this is like over 1, so we invert and multiply, and that's where the squared comes through. And then I isolate the beta 1 here because we need to take that over, factor out the beta 1, and then divide by this quantity here. So anyway, so it simplifies to beta 1 is equal to that quantity.